our next part is how we can really, in today's ever-increasing economy, and we know gas prices are going up and up and up, we want to dwell on heat pump and how today they are actually a viable solution in today's economy to save money. We're going to discuss what they are, what do they do, how do they work. How can a heat pump save me money heating my home? And where does the heat come from? These are two most common questions. Well, first we got to examine what we're trying to do. This is space, and this space represents your house. In the wintertime we heat this space, and in the summertime we cool this space. We commonly call this conditioned space inside your home. Ultimately, what we want is to be comfortable in our home. But we also want to save dollars. All right, heat pumps come in two types. Ground source heat pump, air-based heat pump. The ground source heat pump gets its heat from a variety of tubes residing about 4 feet in the ground. Your air-based heat pump gets heat from the air. But no matter what, in both cases, we need a vehicle. What we do is we're transferring heat from one place to another. Now, both of these vehicles, I don't care which one you need or which one it is, they need a vehicle, and that vehicle is electricity. The electricity moves the heat. It transfers it. It does not create it. And therein lies the savings. We're just moving the heat that is in the ground or in the air already into the house. Now, typically people have an air conditioner and they understand how an air conditioner works. Click it all the way through. What happens in an air conditioner is we take hot air from inside the house, move it along the copper refrigeration lines inside of your basement to the condensing unit, which is outside the house, and we dispense it into the air. And everybody knows, we call it heat transfer. We're transferring heat from inside the house to outside the house. How does a heat pump work? Well, it very much works like your refrigerator. If you take a pound of bacon and you move it from the refrigerator to the freezer, the temperature of that pound of bacon is going to be lower. Well, it just doesn't happen automatically. What happens is we're transferring the heat inside of that bacon to the coils on the back of the refrigerator. The little fan underneath the refrigerator, which runs the little condenser unit, blows that warm air across our toes. Well, the warm air that's blowing across your toes is coming from the pound of bacon that's just put in there. We're simply transferring the heat from the bacon to the coils to the floor of the house. A heat pump works exactly the same way. We take heat from, already absorbs heat from outside air. We move it to the condensing coil on the inside of the house, and we use the fan or electricity to move that air into move that warmth into the house, that heat into the house. Moves heat from outside to inside. Now, how can a heat pump save me money in my home? Well, you only pay to move the heat. You're not paying to produce the heat, right? It's less costly. Next slide. This is just a comparison of typical prices of costs of energy, and I know it's a little hard to read, but the top line is what oil prices have done. The red line is what LP or propane has done, and I'm not telling you, if you got LP or propane, it's gone bonkers. It's gone anywhere from 38 cents a gallon back in 1995 to the most current number I could get is $1.89, which is down from $2.70 at the beginning of the season. Natural gas has gone from a therm, from about 50 cents a therm, all the way up to currently at about $1.40 a therm. But electricity is its bottom line. Electricity between 1995, we were paying half a cent for a kilowatt. Today we pay 8.5 cents per kilowatt. In other words, fossil fuels, natural gas, LP, I don't want you guys, have more than doubled, where electricity rates have remained relatively the same, or relatively low. So the question then is, when it's 0 degrees outside, is there enough heat for the heat pump to still move heat to my house? The answer is, so in other words, when it's real cold outside, what do I do then? Well, that's where you need an auxiliary source of heat. In southern climates, they use electricity. And what they have is these huge toaster strips inside of these boxes, and these toaster strips start to glow, and that electric meter starts to go, okay? And we blow heat into the house. Up here it's not practical because it'd be too costly. Up here we use an alternate source of heat, perhaps the solution is a backup gas furnace for backup source. Wherein today we have out there in the world, we have hybrid cars. Cars that run on electricity, cars that run on gas, same car. Today we have hybrid heating systems. Electricity, gas, backup. Very affordable. We call that dual fuel. It is the most, and what you do is you use the most cost-effective fuel source. If gas prices drop, then you use the gas burner. If gas prices remain high, you heat with electricity and only heat with gas when you need to. Digital comfort controls operate either system. It switches over. It uses the thermostat as a guide, tells the system what's the most affordable opportunity for you in your house. What's the best solution? An example of how a hybrid system can work is your fossil fuel system at 17 degrees, your furnace will give you 92 cents of heat for every $1 spent. 92% efficient. A hybrid system using electricity and gas will give you $2.72 for every dollar. That's a big difference. Again, heat pump facts, and just some quick heat pump facts. Our digital controls today bring the fossil fuel if the indoor temperature drops 1 degree or if the outdoor temperature is low enough that the heat pump cannot produce enough heat to keep your home comfortable. The staging heat produces a constant temperature within the home, with more comfort control than conventional just fossil fuel furnaces. And one of the other heat pumps is, yes, we can exactly extract heat all the way down to absolute zero. It's not practical, but absolute zero we can get heat still in the air. And we drive this home by saying, look, if heat pumps didn't work in our climate zone, why is largest sellers of heat pumps in the world Canada? They're above us.